Slope and deflection of determinate beams by Castigliano's second theorem. This method is basically just the same with the virtual work method. It's just that it simplifies the integration of a certain segment by not having any virtual beam anymore. Instead, we are going to place immediately the virtual load to which deflection or slope are being asked. Theorem. For linearly elastic structure, the partial derivative of the strain energy with respect to an applied force or couple is equal to the displacement or rotation of a force or couple along the line of action. So it's actually just the same with the virtual work method, but this time we're going to partially get the equation of a certain structure in which deflection and rotation or slope are being asked. For deformation, all we have to do is get the integral of the product of the moment equation of the real beam together with the loads and also the applied P or moment, and also the partial derivative of the moment with respect to P dx. And the limit is from 0 to the length of the segment. And that direction downward is basically the assumption to which your deflection may after the load are being applied. For slope, it's gonna be the product of, or the integral of the product with moment equation of a certain segment times the partial derivative of the moment equation with respect to m prime, since the m prime is the virtual work, or not virtual work, but the virtual load, rotational load, or moment or couple to which your slope is asked. And the direction would be the assumption to which the slope may rotate in a certain direction. So here are the elements definition. So small letter delta is the external displacement of the point caused by the real loads acting on the beam or the frame. And then theta is the external rotation or displacement, rotational displacement of the point caused by the real loads acting on the beam or frame. P is the external force applied to the beam in the direction of the deflection. And M prime is the external couple acting at the point where the slope is to be determined. Remember that we are still not going to mix the P load solution from the M prime moment solution, since both are not the same. Capital letter M is the internal moment of the beam or frame expressed as a function of x and caused by both P or M prime and the applied loads in the beam. EI, of course, is the flexural rigidity of the beam. Procedure of the analysis. Number 1. Place a force P on the beam or frame at the point and in the direction of the desired deflection. Also, in case for a slope, place the couple or M prime at that point of desired slope. Number 3. It is assumed that P and M prime have variable in magnitude. Number 4. Establish appropriate x coordinate that are valid within the regions of the beam and frame where there is no discontinuity of the material, section, and loading. Number 5. Calculate the internal moment m as a function of P or M prime and each x coordinate. Also compute the partial derivative of m with respect to P or the partial derivative of m with respect to M prime for each x coordinate. Number 6. Set the P or M prime equal to 0.